So, like I said, chapter 12 is on three-dimensional figures. We'll go over surface area of three-dimensional figures and volume as well later on. So just to begin with, we're going to look at three-dimensional figures and how they're viewed and if there's a plane cutting through them, stuff like that. So that's what we're doing today. So to start out, we have isometric views or corner views. Okay, are drawn on dot paper to represent three-dimensional figures on two-dimensional paper. Okay, so an example of this, video game programmers use technology to make the gaming environments appear three-dimensional. As players move in the various video game worlds, objects are realistically shown from different perspectives. Okay, so in different games, okay, you do have these three-dimensional objects. They use this kind of view to create those objects. Okay, that's why it's important to use. So in the two examples below here with the dot paper, we are going to create these three-dimensional shapes. So number one, we want to create a cube with 4 units on each side. Okay, that means each length has to be 4 units. So if I start off this way, I have 1 unit here, 2, 3, 4. Okay, same thing this way, 1, 2, 3, 4 units. Okay, since it's a cube, that means it is a parallelogram. So the side opposite, this side here, has to be parallel to it. So I'm going to draw in another one. 1, 2, 3, 4. Okay, same thing with this side. Its opposite side has to be parallel. 1, 2, 3, 4. Okay, this isn't a cube yet, right? It's only two-dimensional so far. So what I'm going to do is draw in a straight line down 4 units from each of these vertices. Okay, and then I'm just going to connect each of those endpoints. That's 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then you want to look at it three-dimensionally. Okay, so think about a cube and what it's supposed to look like. You're not trying to imagine it just sitting on a piece of paper in two-dimensional. You're trying to think about it three-dimensionally. So you want to kind of see that cube formed. Okay, do you see it? Yes? All right. So in number 2, we want to again draw a cube, this time with sides that are half the cube in number 1. So if this one was 4 units, how many units should this one be? I say that. Okay, so this one should be 2 units. Okay, so I want you guys to draw that one. Okay, it's similar to the first one we just did. You can start drawing it in. You can start anywhere. It should fit. 2 units on each length. Try and draw that in on that dot paper.
I did it. I think I'm going to go home making a grandparent house. With the milk I did it. No, without milk cutting.
You draw a straight line so effortlessly, but I can't do it. It's a good drawing straight line.
I'll make it thin this time. I'm an architect now.
First one, easy peasy, lemon squeezy. Second one, no.
All right, so number 2, yours doesn't have to be on the exact points mine is. Okay, it could be up in this corner, on the side, doesn't matter.
No, it has to be.
Okay, but each of your lines should be 2 units long. Okay, so 2 units here. Shh, quiet now. 2 units here. 2 units, 2 units, 2 units. Okay, so all the way around, it has to be that same length. Okay, any questions on drawing these in dot paper?
What's the point of it?
What's the point of drawing it? Like I said up here. So this is what programmers use. They use dot paper like this to make things appear 3-dimensional, even though it's drawn 2-dimensionally. So it's a little bit easier to see it 3-dimensionally when you draw it on this kind of paper. All right, so next we're going to look at cross sections. Okay, so that is the intersection of a solid and a plane. Okay, so that intersection is called a cross section of the solid. Okay, so a plane is flat and 2-dimensional. Okay, so it's like your sheet of paper. Okay, that's a plane. It's straight, it's not curved. Okay. Now, if that cuts through a 3-dimensional figure, the shape formed by that intersection is called your cross section. Okay, so the shape of the cross section depends upon the angle of the plane. Okay, so your plane doesn't always have to be flat. Okay, doesn't always have to be flat. It can be angled. Okay, angled, sideways, stuff like that. So, examples of this. There are several intersecting shapes that are cross sections of a cone. So we want to determine the shape resulting from each cross section of this cone. So if the plane is parallel to the base of the cone, then the resulting cross section will be a circle. Okay, so if I look at this cone, okay, cone is like an ice cream cone, right? Okay, so this here is a 3-dimensional shape, that cone. This is your plane, okay, that's cutting through it. Now it is parallel to that bottom line of the cone, and that intersection that's created is right here. Okay, that intersection is then shown at the right here. So this rectangle is your plane, and this is the piece that it hits from your cone. Okay, so you can clearly see that it creates that circle shape. Does that make sense? If a plane cuts through it, you're looking at that intersection of both figures. Okay, so another example, if you go to the back. Letter B, again you have a cone. Okay, so if the plane cuts through the cone perpendicular, okay, so perpendicular to the base and through the center of the cone, then the resulting cross section will be a triangle. Okay, just because it's a cone and you had a plane cutting through it doesn't always mean it's going to be a circle like example 1. In this example, your plane, this rectangular piece right here, is cutting through the top of your cone. Okay, so right here, it forms this triangle shape from that intersection. Okay, and you can see that here. If you were to take that plane, too much talking. If you were to take that plane and just the intersection made to the right here, you would see that triangle then is formed. Okay, you kind of seeing that? I know it's kind of hard to think three-dimensionally when you have a 2-dimensional piece of paper in front of you. Okay, the last one here, letter C. This time, the plane cuts across the entire cone. Okay, so this plane is now angled. So like I said, it's not always straight. This one is angled. Okay, plane is angled this time. Then the resulting cross section will be an ellipse. It's an oval. No. The mathematical term for oval is an ellipse. Okay? It's called an ellipse, not an oval. So, looking at your cone, the three-dimensional cone formed here, and your plane that's at an angle, it does cut through and hit this part right here. Again, that's over to the right here. You have your plane, and then the cross section created is that oval. Yep. How is it an oval?
How did it cut through but not like grab anything else from the shape?
How did it not grab anything else?
Like how it made this with an oval, but what about like the sides of it? The things that it cut.
What other things did it cut? The only part that this plane hits, because it's flat, it's two-dimensional, it's not three-dimensional. So if you...
Oh, I thought it was like this.
No. So planes are just flat and two-dimensional. And they're made up of points. So if I were to cut through something at an angle, you're looking at the cross-section of that intersection. Yeah, so this one is sideways. Yeah, you kind of see it now. So since it's sideways, you have that oval formed then. It stretches out the circle. Okay? Yes. I don't have my charger. All right, so are we good on this section right here?
Sure is.
Okay, so in this next one, I want you guys to read through it and then answer these 4 questions. For this last one, you can use your phone or you can use a computer to help you. Okay? For the first 3, look at the pictures above. It tells you which cut it is. Okay, and you have to identify that cross-section shape.
Where's the long? Bet you it's in Egypt.
So think about what a pyramid looks like, okay, and how you could cut through it.
Mexico.
Oh, it's in Mexico.
Is that Mexico?
I knew it.
What? Well,
Isn't crazy as that stuff.
it's in Wisconsin. It's in my backyard.
It's actually in my pocket.
Oh yeah.
Oh, the inflatable one?
Mexico.
Cameron, you'll would start what?
Huh?
You'll would start concept.
If we play dodgeball today, you're gonna stop me. You're gonna help.
Jared's gonna help you.
Actually, I think.
Jared, you best be my team then.
Jared's gonna
Do you think Jack would?
No.
You think Jack would?
Yes.
Jared will be a traitor.
Charlie, how do we say this for not botching
Pause
this?
it on my head.
Charlie,
What?
come here. How are you supposed to say this without like destroying it? Oh. Because I don't want to destroy it.
I found out Lily's book reading.
Chalupa, bro. Taco Bell, chalupa.
I was everybody at court today.
Oh.
Even though we all know it shouldn't be out.
Oh, big
Why was it sitting like right in front of us? Yeah, we just let it. We walked in. No, I would put it.
All right, quiet for me, please. Bringing it back. All right, so we do have a square pyramid here. Okay, so since it is a pyramid, it does have 4 sides. and it means it has a square base. Okay, so the base at the bottom is a square. So, if we were to cut that pyramid horizontally for that plane, okay, so horizontal to the base, what kind of shape would then be created? A square.
I wrote rectangle.
Oh, that's right.
Okay, it is a square. Now, keep in mind that a square is also a rectangle. Okay, a square is also a rhombus. Okay, so yes. Okay, so it's more specifically a square. However, a square is also a rectangle and a rhombus. So you were correct if you wrote that as well. For the second one, now this cross section is angled. So if you think about your pyramid, as you go up to the top, what happens to each side? It gets more narrow, it gets shorter, right? So if I'm looking at this side closer to the top, it's going to be shorter than this side towards the bottom, correct? So if those two sides are parallel to each other, right, but one piece is shorter than the second piece, what shape does that create? A trapezoid.
I don't look like a trapezoid.
Okay, so when you're looking at a picture like this, yes, it doesn't look quite like a trapezoid in the picture drawn. But you have to think about what that three-dimensional shape actually looks like. Okay, so like I said, it gets narrow towards the top. So that means that smaller piece at the top, okay, is going to be smaller than the larger piece at the bottom. Okay, then your other two sides is going to angle downward. So that is how we create a trapezoid there. Okay, then our vertical cross section. So we're cutting it straight down from the top to the bottom. So what is that?
That's a circle.
It's a triangle.
That's a parallelogram.
Okay, so you should create a triangle as you cut it vertically. Shh, we're paying attention, remember? So if I were to just take, I don't know, a knife and it was a cake or something, cut it straight down the middle, okay, it would form a triangle on those cut pieced sides. Okay? Last one, largest pyramid is in Mexico. Okay, it's not in Egypt, it is in Mexico. Oh, yeah.
Yeah, that's my backyard.
All right, last, shh, quiet please. Last section here. So Ramona has a cake pan shaped like half of a sphere, as shown at the right. Okay, this is half, shh, be quiet please. This is half of a sphere. Describe the shape of the cross sections of the cakes baked in this pan if they are cut horizontally and vertically. So think about a half sphere cake. If you were to take your knife to cut the cake horizontally, so you're going to go through the middle. So what kind of shape would be formed if you were to take the top off then and look at that cake? It would be a circle.
I'm pretty depressed if I got a cake and somebody just started cutting it.
Okay, then the next one. Shh. Next one is a vertical cross section. So again, if you have your whole cake, that half sphere, again, you take your knife to cut the cake and you go straight down the middle and then you open it up, right? What shape would be formed there?
That's a half circle.
A semicircle.
What are straight lines then?
Okay, it would be a semicircle.
I wasn't thinking about like
I love how
a
confident
fat
she
type
was.
cake. I was thinking like a
Triangle.
Okay, so quiet, please. Okay, so here's your vertical cut. Okay, you have this shape formed here. That is a semicircle. Okay, or a half circle, you could say as well. Same thing. Okay, does that make sense about how you have to change how you think about when you're looking at this? Okay, so if you have to think about your three-dimensional shape as a cake. Some of them might be a weird-looking cake, but then if you're trying to see if you're cutting it vertically or horizontally or an angle, it's a little bit easier because then you can pull the cake apart and see what shape is formed. Okay, so you have to wrap your mind around that.